measured parallel to the floor means the horizontal distance. So is the condition what we discussed earlier is it is as the two pegs are fixed on a wall means the line joining the two pegs is on the wall. It is parallel to the vertical plane and inclined to the ground. So when a line is inclined to the ground and parallel to vertical plane, true length is in front view. True length is in front view. So this is A dash, B dash, and reduced length is in top view. So top view length is given as the distance between the pegs measured parallel to the floor is 4 meters. So it is the top view length. AB equal to 4 meters. This is we discussed in last class how it is. If one peg is 1.5 meters above the floor, so let it be A dash. So above the floor is in front view, A dash is 1.5 meters above XY line. 1.5 meters above XY line. Find the height of the second peg and also ask it to identify the inclination of the line joining the two pegs. So before moving to the problem, here the dimensions are given in terms of meters. But on our drawing sheet, it is not possible to represent in meters. So we have to reduce the values. So we have to reduce the values based on the ratio. So ratio ఎట్లా calculate చేయాలండి? Suppose if it is 1.5 meters, what is the convenient length? Any of you? So you can represent this 1.5 as 15 mm. Is it a convenient dimension which you can represent it on the dimension? 1.5 meters is a convenient dimensions which we can 1.5 meters, because as you can't represent 1.5 meters, we'll represent it into 15 mm. So in the same ratio, the remaining two values to be converted. So what is the ratio here? So ratio is given as scale or RF ratio is calculated as actual representation on the drawing. So representing on the drawing as 15 mm by actual value. The actual value is 1.5 meters. 15 mm by 1.5 meters. So it is 15 mm by 1.5 meters means how many mm? Any of you? 1.5 meters converted into mm.
1500.
1 meter equal to 1000 mm. So it is 1.5 into 1000, 1500 mm. So cancel changing. Simplify this ratio. It is 1 by 100. Is it? So it is 1 by 100. In the same ratio, we can convert this. Convert this 4 meters by multiplying it with 1 by 100. What is the value? 4 meters means 4000 into 1 by 100. What is the value? It is
40 mm.
40 mm. Similarly, this 6 meters. 6 meters, it is equal to 60 mm. 6000 into 1 by 100. So here this 1 by 100 is called as scale. I think some of you are completely writing the title block. If you have the sheets, in the title block, there is a term called scale. So this scale implies, suppose if you are reducing or enlarging any drawing, instead of drawing it to the actual size, if you are reducing or enlarging, here you are reducing. So it is a reduction scale is 1:100. We are reducing the actual drawing to 1:100. Now, So first I'm giving time 1 minute. Write down these values. Write down these values. So reducing a scale to, we are reducing the scale to 1 is to 100. Reduction scale 1 is to 100 we are using. So actual drawing it is given in terms of meters and we are representing in terms of mm. So for convenient purpose, I'm erasing this. So using a scale of 1 is to 100. Now, drawing. First draw XY line. Draw XY line and represent. So what I said earlier, we'll start with a point for which we know the front view and top view locations. We will start with a point for which we know the front view and top view locations. So we know the location of A dash. What about AB? Any of you? Where point A and point B exist? Where point A and point B exist?
On XY.
On XY. Why? Because the pegs are fixed on the wall, means the two endpoints are on the vertical plane. When the points on the vertical plane, its top view will be on XY line. So A comma B, top view of point A and point B are on XY line. Or on XY line. So first we know the location of A dash and A. So A dash is 1.5 meters above XY line. We're converting it to 15 mm. So mark point A dash 15 mm above XY line and point A so let this be A dash and A. Now AB equal to 4 meters. AB equal to 4 meters and we converted into 40 mm. So AB length equal to 40 mm. So from A at a distance of 40 mm, mark a point on XY line and indicate this point as B. At a distance of 40 mm from A, mark a point on XY line and indicate this B. So this is the top view of the line AB. Now for getting the front view. So front view, how to complete the front view? The condition is always A dash lie on the same projector. In the same way, B dash lie on the same projector. So draw a perpendicular line from B. Draw a perpendicular line from B. So indicating as a projector of B. Now B dash exists somewhere on this line. B dash exists somewhere on this line. So for getting the B dash, we have one more data, that is A dash B dash distance equal to 6 meters. Means we converted it into 60 mm. So the distance between A dash B dash is 60 mm. So now take compass, set radius equal to 60 mm. A dash as center, 60 mm radius. Draw an arc on the projector from B. The intersection point will be B dash. Join A dash B dash with a straight line. Join A dash B dash with a straight line. So this is the final drawing. And how to represent the dimensions, the most important one. So be careful how to represent the dimensions for this problem. Actual dimensions are 1.5 meters and we converted it into 15 mm. Till now, what we are doing is we are simply representing the dimension values but not the units. Why? Because every dimension, everything we are taking as mm, and at the end above the title block we are writing it as all the dimensions are in mm. So we are not representing dimensions on any figure or any answer. Now, but here the dimension is in terms of mm. We have to meters, we have to write it as 1.5 meters. For this problem, you have to represent the dimensions. 1.5 meters, meters only. Even though you have completed this drawing in terms of mm, but we have to represent the dimensions as given in the problem. Point A dash is at a distance of 1.5 meters. Similarly, the distance between A to B, distance between the two pegs measured parallel to the ground. How much is this value? It is 4 meters. Write the value 4 meters. I'm coming to distance between A dash to B dash. The distance between the two pegs. Represent this as 6 meters. Represent this as 6 meters. So the dimensions to be represented are 1.5 meters, 4 meters, and 6 meters. So for clarification purpose, at the bottom, within the guidelines of 4 mm height. So remember this, everywhere we're going to use the same guidelines. Within the sheet means it is a guidelines of 4 mm height, right, as scale. Scale equal to 1:100. So instead of representing as 1 meter, we are converted into 1/100th of a meter for calculation, for drawing purpose. Now, in problem, he asked to identify the distance of second peg above the ground level. He asked to calculate the distance of second peg above the ground level. So what you have to do is distance of second peg above ground is, so be careful. If you measure with scale, we'll get the value in terms of mm. Is it? Suppose if you got this value as some 40 mm. Suppose if you got the distance between B to B dash at a distance of 40 mm above the ground. Multiply it with reciprocal of the scale, that is multiply it with 100. So taken the ratio 1:100. So multiply it with 100. So what is the value?
4,000.
It is 4,000, means write it as 4 meters. Suppose if you got 41 mm, write it as 4.1 meters. Suppose if it is a 42 mm, write it as 4.2 meters. So convert the value into meters by multiplying the value into 100. Actually, I'm not drawing as per the dimensions, so I won't get the exact value. But while drawing, measure this value with scale, multiply the value with 100, and write down the exact value what you are getting. So the exact value what you are getting is in terms of meter. At the same time, calculate this angle theta. So he's also asked to calculate the inclination of the line joining the two pegs with the ground. So that is theta. So measure the value of theta and also write at the bottom. So we have to write 3 statements. First is scale. Second one is distance of second peg above the ground. And third one is the inclination. So wherever, if you reduced or enlarged the given dimension, then you have to represent the scale value. we have to indicate the scale value below the figure. And in title block also we are having scale, but default is we are not reducing or enlarging any dimension. This is the only problem we are using in this sheet. So entire sheet in the title block represent the scale as 1:1, but only for this problem represent as 1:100. Shall we move on to next topic? So I'm giving time for 1 minute. Copy this if anyone want to copy. So with this we completed projections of lines. 1 means the lines in simple position, either parallel to both the reference plane, parallel to one reference plane and perpendicular to the other. Third condition is parallel to one reference plane and inclined to the other. Parallel to one reference plane and inclined to the other. Now let us move on to the next sheet. Sheet number 8. Sheet number 8, give the title as projection of lines inclined to both the planes, or projections of lines 2. The next topic is projection of lines to sheet number 8. So the problems what I am discussing from now, draw it on a new sheet. Up to this problem, these 6 problems completed in sheet number 7, and next one is sheet number 8. Now, when a line is inclined to both the reference planes. So before going to start a new topic, let us revise one more time. When a line is inclined to horizontal plane, how the configuration figure looks? So observe the problems what you have completed in the previous class or this class. When a line is inclined to horizontal plane, x-axis, sorry, xy line. So this is the shape. And what is this angle? Theta. The angle is theta. When a line is inclined to horizontal plane, will represent the inclination with the horizontal plane as theta. And what are these points? Let this be A1 dash, B1 dash, A1, B1. The true length of the line, A1 dash, B1 dash is true length of the line, and A1, B1 is top view length. A1, B1 is top view length. Maybe the dimensions may vary, length of the line may vary, or the distance of the points from the reference line or the reference planes may vary, but the overall configuration of the figure looks as a trapezium shape in this way. Similarly, when a line is inclined to vertical plane, when a line is inclined to vertical plane, we'll get the shape like this. Is it? Line inclined to vertical plane, angle phi. It is seen in top view, and in front view it looks as a line parallel to front view, looks as a line parallel to xy line. And what are these points? That it be A2 dash, B2 dash, A2, B2. A2 dash, B2 dash, A2 and B2. These are X, Y, and here it is the true length. It is the true length, and this is the front view length. This is the front view length. So just refer the previous problems, problem number 2, 3, 4, and 5. You'll get only these two shapes. Maybe the distance of the points from reference line xy may vary, or the length may vary, and the dimensions may vary, but the overall configuration figures are these two. When the line is inclined to horizontal plane, when the line is inclined to vertical plane. Now, when a line is inclined to both the reference planes, when a line is inclined to both the reference planes, just first step is overlap these two figures. Overlap these two figures. And here one consideration is we have to choose any one fixed point, either A or B. Depending on the problem, we have to fix one point as a reference point. So default is first point, assuming it as a fixed point, and the second point is rotating, the line is rotating about that fixed point. Suppose if we assume A as a fixed point, the first case, when the line is inclined to horizontal plane. I'm redrawing this figure again. Is it visible?
Yes, sir.
Yes or no? So there is the XY line. What are the points? A1 dash, A1, B1, B1 dash. So as I'm taking A as a fixed point, I'm taking only A dash and A. The other endpoint as B1 dash, B1. A has a common point for both of them. Now, writing on this, overlapping on this, when the line inclined to vertical plane. So here I'm also representing this angle, theta, true length, and top view length. I'm overlapping on this, the condition when the line is inclined to vertical plane. When the line is inclined to vertical plane. Angle 5, B2 dash and B2. B2 dash and B2. Now, if you observe, when a line already inclined to horizontal plane and it is made inclination to the vertical plane, and we add the one more value, that is inclination to the vertical plane. So it already inclined to horizontal plane only, and we are making this line inclined to vertical plane also, means we have to rotate along this direction or this direction. So if you observe, already when a line is inclined to horizontal plane and you make it inclined to vertical plane also, the distance from the ground of the second point doesn't changes. Even though if you rotate it inclined to vertical plane, the distance of the second point, first point already fixed. When it is parallel, when it is inclined to horizontal plane, and if you make this further, the line inclined to vertical plane also, if you observe, even though it is rotating, the distance of the point from the ground level doesn't changes, which implies the final end point of the projection in front view exists in the same height from the XY line. So I'll indicate this as locus of B dash. No, on the locus of B dash, B1 dash నుంచి వచ్చిన horizontal line మీద, the B dash point will exist. In the same way, when a line is inclined to vertical plane and you make it inclination with horizontal, and you make it inclination with horizontal, the distance of the endpoint, second endpoint, with respect to vertical plane doesn't changes. The distance of the endpoint with respect to the vertical plane doesn't changes. Based on this concept, this is the point B2. We will draw a horizontal line passing through B2. This is locus of B. This we'll call it as locus of B, means the final projection when the line is inclined to both the planes. The final endpoint of B exists on this line, and the final endpoint of B dash will lie on this line. How to identify? So before going that, this is the condition when the line is inclined to vertical plane. So this is true length of the line, and this is front view length. Front view length, top view length, and these two are the true lengths. A B2 is the true length, is also equal to A dash B1 dash. Why? Because these two lengths are the true lengths of the line, and front view length and top view length as it is. Now, for getting the final front view and the final top view, the condition is with A dash as center, A B2 radius. A dash as center, A B2 radius. Draw an arc. A dash as center, A B2 radius. If you draw an arc up to B dash, represent this arrow also. Why? Because we are rotating this line. This is the final endpoint of B dash. So front view length, with the front view length, draw an arc with A dash as radius on the locus. Similarly, with top view length as radius. Top view length means A B1. Top view length radius, so A as center, if you draw an arc. A as center, if you draw an arc. The point where it is intersecting the locus is point B. Is the point B. Now, A dash B dash, the final front view, and AB is the final top view. A dash B dash is the final front view, and AB is the final top view. And one more cross checking is, after completion of this, if you join B B dash, if you join B B dash, so the condition always is B B dash must lie on the same projector. B B dash must lie on the same projector. So if you join B B dash line, the line must be perpendicular to XY line. So final line with draw చేసింది perpendicular గా రాకపోతే, it implies you did somewhere mistake. You did somewhere mistake. So this is how to represent when a line inclined to both the planes. So I will explain this on the PPT. Just wait for a while. Any of you are noting down? So I'll give one more minute time. Just copy this. I will show it on the PPT. The same two figures. One more time I'm going to explain it on PPT. Can you see the screen now? So projections of lines we completed. When the line is inclined to horizontal plane and when the line is inclined to vertical plane. Now, when the line is inclined to both the planes, alpha and beta are the apparent length, what we can see after projection. Theta and phi are the true lengths of the true inclination of the line with reference plane. Now, this is how it looks, the final front view and final top view. But we won't get these lines directly. So for this, we have to follow a procedure. First step is overlapping the condition. So this is when a line is inclined to horizontal plane with an inclination theta. Here it is represented as P, P dash, P and Q. And on board I have shown it as AB. So when the line is inclined to only horizontal plane, so we'll get this trapezium shape. Is it? True length of the line, P dash, Q1 dash, inclined at an angle theta with the horizontal plane. And when the line is inclined to vertical plane, we'll get a shape like this. So and depending on the dimensions and the angles, the lines, in some cases, P Q2, Q2 dash is inside, and in some cases, Q1 dash is inside the figure. So don't confuse, just it is a representation, and this is not as per the dimensions. And now, when the line is inclined to vertical plane, so when the line is inclined to vertical plane, the true inclination and the true length is shown in top view. PQ is the true length in top view. P dash Q1 dash is the true length in front view. Similarly, PQ1 is the top view length. P dash Q2 dash is the front view length. Now, after completing this, draw a horizontal line passing through Q1 dash. Draw a horizontal line passing through Q1 dash, writing it as locus of Q dash. And similarly, draw a parallel line to XY. Parallel line to XY or horizontal line passing through Q2. Naming it as locus of Q. Locus of Q dash, locus of Q. So these two are the lines parallel to XY passing through Q1 dash, and locus of Q is a line parallel to XY passing through Q2. So somewhere on this line the Q is exist, somewhere on this line the Q dash will exist. Now after getting these two, take compass, set radius equal to P dash, Q2 dash, and draw an arc till it intersects the locus. Draw an arc till it intersects the locus. And this intersection point is Q dash, the final end point of the projection in front view. Similarly, take the length equal to top view length, that is PQ1, top view length radius. So if you draw an arc up to the locus of Q, the point what you are getting is final projection of point Q in top view. This is point Q. Join the final front view and final top view with HB pencil. So if you observe this figure, only the final front view and final top view are represented with HB pencil, highlighted. Remaining all the lines are drawn with 2H pencil. Why? Because remaining all other are only the construction lines. The final line what we require is final front view, P dash Q dash, and the final top view, PQ. This is the only final drawing what we require. Remaining all other are constructions for getting this projection. Now representing all the features on the figure. So I'm giving time 5 minutes time Note down all these points, including this figure. Why? Because this figure is most important for solving the remaining problems. I'm giving time. Draw this figure. So figure diagram చేయడం difficult కాబట్టి first draw this figure, just overlapping the front view inclination and top view inclination, or horizontal plane inclination and vertical plane inclination, and move on to this. After completing this, we will write down the data. So I'm giving you 5 minutes time. Note down this figure. It's important. Why? Because even for drawing the next figure, going to the problems, we require this configuration figure. Start drawing. First, draw this initial figure, and on this figure, draw a horizontal lines indicating the locus of Q dash and Q, and then draw an arc with radius equal to P dash Q2 dash. Join P dash Q dash PQ, indicating the final front view and the final top view. So these projections of lines inclined to both the planes is little bit complicated compared to the projections of lines inclined to single plane. So if the direct problem is given, direct problem means true length of the line and theta phi values, that is inclination with the horizontal plane and inclination with the vertical plane. If these data are given, we can solve the problem by this method, what I have explained just now. But every time the problem may not be in the same order, that is simply directly giving the true inclinations and true length of the line. Most of the cases, they're going to give different data other than true length of the line and true inclinations. So for that one, we have to understand the relations between various points in this figure. This is called as the configuration figure when the line is inclined to both the planes. And also write these data on the line. So no need to write the complete value, just write it as true length, final top view, final front view, XY line, I think no need to indicate this XY line, locus of Q, locus of P dash, locus of Q dash, like this. Is it completed? So if you observe the inclination, theta is different from alpha. The true inclination is different from the apparent inclination. So in the final view, we can see only the apparent inclination. So alpha is the inclination of projection line with respect to xy in front view, and beta is the apparent inclination in top view. The inclination of the top view with xy is beta. The inclination of the front view with xy line is alpha. And what are theta and phi? Theta is inclination of the line with horizontal plane, and phi is inclination of the line with vertical plane. So remember, for representing theta and phi, we'll term it as the inclination with respect to horizontal plane and vertical plane. For indicating alpha and beta, we'll term it as inclination of the front view with xy and the inclination of top view with xy. We'll not represent it with respect to HP or VP. So this will be inclination with HP. Apparent inclination is always with XY only, not with respect to HP or VP. It is only with respect to XY line. Now, is it over? Just I'm showing the board on board better. I'm skipping this. Yes. Can you see the screen now clearly? Now on this figure, you have represented everything with A dash B dash. The convenient general method is AB or PQ, whatever it may be. The notation is not important, but fixed point as a single point. So if you observe, A doesn't have A1, A2 or some other points. Why? Because A we are assuming it as a fixed point. B, we are rotating the line with respect to point A. So that's why we are assuming A as a fixed point. Now, if you observe on this figure, what are the true length values? True length, A dash, B dash. A dash, B dash also equal to A, B2. A dash, B1 dash, sorry. A dash, B1 dash also equal to A, B2. It is the true length of the line. Already we indicated A dash, B1 dash, true length, A, B2, true length. And A dash, B1 dash is inclined with an angle theta with XY. A dash, B1 dash is inclined with an angle theta with XY. Theta is inclination with the horizontal plane. Similarly, AB2 is inclined at phi with XY line in top view. This is in front view. This is in top view. Just I'm extracting the data, which will be helpful for solving further problems. Write down this data. Write down this data, what I'm explaining now. So which will be helpful for solving the next set of problems. Now, what is the front view length? A dash, B2 dash is the front view length. Also, how you are getting A dash, B dash? By drawing an arc from A dash, B2 dash. Taking the radius as A dash, B2 dash, we are drawing arc up to the locus of B dash. And we are getting B dash point. So which implies A dash, B2 dash equal to A, B dash. So front view length equal to A dash, B2 dash also equal to A dash, B dash. Front view length A dash, B dash. A dash, B dash is also equal to A dash, B2 dash, which is the front view length. Similarly, top view length equal to AB1 equal to AB. AB1 equal to AB. AB1 equal to AB. And one more observation is B1 dash and B dash. B1 dash and B dash lie on the same locus. B1 dash and B1 B1 dash and B dash lie on the same locus means lie on the same parallel line to XY line. Similarly, B comma B2 lie on the same parallel line to XY line. Along with this, not only these two, A dash B2 dash lie on the same parallel line to XY line. A dash B2 dash lie on the same parallel line to XY line. Similarly, in top view, A B1 lie on the same parallel line to XY line. Now, as I said earlier, the direct problem means they will give the data in terms of true length of the line, theta and phi, and distance of point A from the reference lines. Distance of A dash and A from the XY line. So with these five values, true length, inclination with the horizontal plane, inclination with the vertical plane, distance of A dash from XY line, distance of A from the XY line, we can complete this figure as the process which I explained just now. But along with these dimensions, along with these 5 dimensions, if you observe in this problem, there are other values, that is distance of B dash and B from XY line. Next, alpha beta angles, apparent inclination in front view, apparent inclination in top view, or inclination of front view with XY, inclination of top view with XY. Next, top view length and front view length. So total how many dimensions are there? The basic dimensions are only 5, but in addition to 5 basic dimensions, there are 1, 2, 3, 4, 5, 6 dimensions are there. Total 5 plus 6, 11 dimension values are there in this figure. In these 11, in the problem, they may give any 5 or 6 values and ask us to determine the remaining values. Instead of giving as a direct problem, out of these 11 dimension values, they may give 5 or 6 and ask us to calculate the other values. Like what we did in the inclination of the line, inclined to single planes. In one problem, we calculate the inclination. In one problem, we calculate the distance of point B, second point. In one problem, we calculated the true length of the line. Just refer to the previous problem, sheet numbers 7. So direct problem means the true length of the line and the true inclinations of the given. When these two are given, it is called as a direct problem. So other than this, if you ask to calculate the true length of the line or the true inclination in reverse by giving the front view length or top view length or apparent inclinations, it is an indirect problem. So let us start our discussion with the direct problem. That is when the direct dimensions are given. So for that one, I'm stopping the presentation. I'm stopping the video. So this is not sheet number 7, it is sheet number 8. Note on the first problem. Note on the first problem. In the simple form, try to indicate the data in the simple form. No need of and writing the entire problem. Write it in the simple form.
Sir, could you please send the WhatsApp group?
Yeah, I will say share this. Actually, I don't have this file directly. No need of all these problems. That's why I'm not shared. I will share it as a. I think all of you are online, so I'm sharing it in the chat box. Okay. So first I'm sharing the two problems. After completion of the class, I will share it in the WhatsApp. You can also see it in the chat box. You can also see it in your chat box. First problem. So first note on the first problem. Is it completed? I'm stopping here. Just check it in the chat box. It is also available in the chat box. A line AB 90 mm long. So it is given as true length of the line. So before starting the problem, I'm drawing roughly the configuration figure here. I'm drawing roughly the configuration figure here. Actually, no need of configuration for this problem. So the given data is line AB 90 mm long, means true length of the line 90 mm is inclined at, it is not 400, it is inclined at 40 degrees to the HP, means theta equal to 40 degrees and 25 degrees to the vertical plane. Phi equal to 25 degrees and end A is 10 mm above the HP. Above the HP means front view location of point A. So A dash is 10 mm above XY line and 25 mm in front of the vertical plane. So vertical plane implies top view location. So point A is it is in front. In front means below xy line. 25 mm below xy line. So as I said, the initial direct problem, the 5 values are given: true length, true inclinations, and any 1 points data with respect to xy line. The first 5 basic data. So for starting this problem, start it with a 2H pencil. Only the final front view and final top view must be with XY with HP pencil. So first draw XY line with H pencil. X, Y. So in this the fixed point is A. So the position of point A, dash and A are given. So always first step is represent this data step by step in the figure. So we know the position of A dash and A. A dash 10 mm above and A 25 mm below. So these are the points A dash and A. Next, the line is inclined to horizontal plane at an angle of 40 degrees. So the horizontal plane inclination first with 40 degrees inclination. So just points note చేసుకోమని చెప్పాను చూడండి just now. The true length of the line equal to A dash B1 dash also equal to, so true length of the line, it is nothing but A dash B1 dash also equal to A B2. Is it or no? A dash B1 dash also equal to A B2, and A dash B1 dash is inclined at theta to HP XY line, and A B2 is inclined at phi with XY line. So with A1 from A1 dash, draw an inclined line length equal to 90 mm at 40 degrees. With 40 degrees inclination, draw a line length equal to true length 90 mm. The end point is B1 dash. But this end point is B1 dash. Now, starting from A, so already got B1 dash. Where B1 exists? B1 ఎక్కడ ఉంటుంది? From a projector from B1 dash. B1 exists on a projector from B1 dash and a horizontal line from A. So this is the location of B1. B1 always exists on a projector from B1 dash. So this is the condition when the line is inclined to horizontal plane. Next, when the line is inclined to vertical plane, phi equal to 25 degrees given in the problem. So starting from A with 25 degrees inclination line, draw a line up to 90 mm line with inclination 25 mm. With inclination 25 mm. Now, what is this point? A B2. That is the point A B2. So for getting B2 dash, so we got top view point, front view point, respect to front view point B2 dash. So B2 dash kavalante, draw a projector from B2 and a horizontal line from A dash. So the intersection is B2 dash. Now we got the first relations, that is line inclined to horizontal plane and the line inclined to vertical plane. Now applying the condition, that is the line inclined to both the reference planes. So for drawing the line inclined to both the reference plane, draw a parallel line to XY line passing through B1 dash. Draw a parallel line to XY line passing through B1 dash and name this line as locus of B dash. And draw one more line parallel to XY line passing through B2. Passing through B2 and name this line as locus of B. So even though I'm writing as a rough lettering, but on drawing sheet, you must maintain the letters height of 4 mm. And one more thing what I observed is, while lettering you are maintaining the 4 mm height, but for indication of points, some of you are writing very small letters which are not visible. Maintain this letter size also the same 4 mm. It should be visible. So entire drawing sheet మీద ఉన్న letters అన్ని కూడా it must be of same size. So ఇక్కడ 4 mm మెయింటైన్ చేస్తున్నాం. So why? Because make it as a practice. ఎందుకు 4 mm చెప్తున్నానంటే 4 mm is a convenient letter height which is visible. So maintain the same letter height for representing these points also. ఈ letters కూడా same size లో ఉండాలి. Otherwise they are not visible clearly. Remember this point. I think I've given comments for 2 or 3 members. Those who written this letter size is very small. Now, after drawing these parallel lines, locus of B and locus of B dash. Now, what is this? True length of the line, and this is also true length of the line. No need to indicate. Just for explanation purpose, I'm writing this. These two are the true lengths of the lines, and A dash B2 dash is front view length and AB1 is top view length. Even though you write it, it is not a mistake, but it is not compulsory to write these terms. Now, take compass, set radius equal to the distance between A dash B2 dash. Set radius equal to A dash B2 dash, front view length, and draw an arc starting from B2 till it intersects the locus of B dash. So this point is B dash. Similarly, with AB1 radius in top view, with AB1 radius, AR center, draw an arc from B. It will intersect the locus of B line, a parallel line to XY line. Name this point as B. So if we checking means if you draw a vertical line from B dash, it must pass through B. So it is compulsory. You must represent the projector joining B dash. So B dash line must be perpendicular to XY line. So my problem no a mistake chesna, it is clearly visible. So means finally these 3 lines must be parallel to each other. The 3 projectors and also the 4 projectors. Total you are drawing 4 projector. A dash, BB dash, B1 dash, B2 dash. All these are the projectors which are perpendicular to XY line. So these 4 lines must be parallel to each other and exactly perpendicular to XY line. So you get exact solution only when you use the drafter. So from this problem onwards, the drafter usage is must. Otherwise, it is difficult to maintain this perpendicular and parallel lines. After getting this, finally join A dash B dash and AB with HB. A dash B dash and AB with HB. Only these 2 lines must be with HB. A dash, B dash and AB. Coming to dimensions. coming to the dimensions given in the problem only must be represented on the final figure. What are the dimensions given? True length, theta and phi. Already I represented these values. On true length also, representing only once is sufficient. No need to represent for both a dash b1 dash and ab2. Representing once is sufficient. So better always represent at the bottom if it is possible. So if the representing at bottom is not possible, represent it in the top view, front view. So bottom lo represent cheyali ante, see here. So actually then what I said is draw the extension lines for 10 mm. But if you draw extension lines only for 10 mm, the dimension line may pass through the point B or this letter B. So extend it for 2 to 3 centimeters depending on the requirement. Draw perpendicular line to A dash B2 dash extension lines. 2 to 3 centimeters depending on the problem, and then draw a parallel line to AB2 line. AB2 line ki parallel ga line draw chesi, and on this line mark the arrowheads and represent the value 90. So be careful, this 90 mm dimension line must not intersect with any other line in the problem. So we have to draw the extension lines 2 to 3 centimeters depending on the requirements. ఒక్కొక్కసారి 5 centimeters కూడా draw చేయాల్సి రావచ్చు. It depends on the problem. And other dimensions missing are distance of A and A dash from XY line. What are these values? 59, 10 and 25. 10 mm and 25 mm. Is it completed? Is it completed? Now, so at the end, he asked to determine its traces. He asked to see the chart box, the final statement of the problem. He asked to determine its traces. Like tangent or normal for the curves, traces are additional values, additional points which we have to identify for the projections of lines inclined to both the planes. So what is a trace? Trace means if you extend a line, so actually it is given as the line is inclined to both the reference planes, that is both horizontal plane and vertical plane. When you extend this line will intersect the horizontal plane and vertical plane somewhere. Is it or not? Definitely it will intersect the horizontal plane and vertical plane. The front view and top view of these points are called as traces. The point where it is meeting the horizontal plane is called as, when you extend the line, actually the line is not starting from the horizontal plane or not meeting at the ending at the vertical plane. But if you extend the line, definitely the points will intersect the horizontal plane and vertical plane. Just wait for a while, I will show you in the PPT. Suppose see in this problem, when a line is inclined to only horizontal plane, if you extend this line AB, the line AB extend చేస్తే ఏమవుతుంది? It definitely meets the horizontal plane at some point. This intersection point is called as horizontal trace, and this horizontal trace is seen in top view. Horizontal trace HT will represent it as HT. It is only seen in the top view. In front view, we can see a point on XY line. We'll represent this point as H. We'll represent this point as H. Similarly, when a line is inclined to vertical plane, if you extend this line will intersect the vertical plane. This intersection point is seen only in the front view. Is it? So the vertical trace is seen in the front view and horizontal trace is seen in the top view. So nothing but, suppose if you extend this line, what happens? Just it will intersect the XY line. So front view horizontal plane law, we can see a point on XY line. So better see it in this figure. Now again take 2H pencil, extend the front view line, final front view projection line, that is extend A dash B dash line till it intersects the XY line, and also extend this. I'm erasing the dimension line. Why? Because it is overlapping here. I'm erasing this dimension line. Just for showing the traces, I'm erasing these dimensions. So if we extend the front view A dash B dash line, it will intersect the XY line. So don't stop it there. Extend it beyond that line. Extend it beyond that point. Name this intersection point as H, where it is intersecting the horizontal plane. Is it or not? When you extend this line, where it is intersecting horizontal plane, it is H. Similarly, extend the top view. Extend the top view line, that is AB line. AB line extend cheste, it will intersect somewhere the XY line. Name this point as V. Small letters, be careful. H and V are small letters. Now, draw a perpendicular line from H. H is a point on extension of front view. Is it? H is a point on the extension line of front view, and the intersection point with the XY line is H. Now draw a perpendicular line from H till it intersects the top view or top view extension line. Top view may intersect avachchu or top view extension line మీద. And this is the horizontal trace. Indicate this as HT, capital letters HT. Similarly, if we draw a perpendicular line from V till it intersects the front view, V nunchi vertical line till it intersects the front view or extension of front view, and name this point as VT. Name these points as VT. So this is how to indicate HT and VT, means the points where the extension of the line will intersect the horizontal plane and vertical plane. In our syllabus, it is only limited to identify the HT and VT locations. But actually, if you refer to the textbook, there are problems where the data is given in terms of HHT, VVT values. Distance of HT, VT from XY lines. E values to only data HE. Ask it to complete the remaining problem. But our syllabus is not extended to that point. We're having only to identify the HT and VT points. Just remember this procedure. So if you complete it, I will move on to the next problem. So meanwhile, go through the second problem in the chat box. Enter the second problem also in the chat box. Just read the problem and try to identify the values. And try to identify the given values in the problem. Start changing. Meanwhile, I will erase this board. So read the problem. The ends of a line AB 80 mm long means the true length of the line is 80 mm. In problem it is given as true length of the line is 80 mm. So what is the true length compared to the configuration figure? True length of the line is A dash B1 dash also equal to AB2. Configuration figure. True length is equal to A dash B1 dash also equal to AB2. Next, the endpoints of the line AB 80 mm long are 10 mm and 35 mm from HP. Means the endpoints front view locations are given. The endpoints front view locations are given. Means A dash B dash from XY line. A dash is 10 mm above XY and B dash is 35 mm above XY. As both the points are from HP, it is given as from HP, in front or above ivoledu. So default is the first angle projection, means we'll assume the line is in the first quadrant, means above the horizontal plane. So front view points above the XY line. Next, and 25 mm and 40 mm from the vertical plane. So vertical plane is called a relation similar, means the default is in front of vertical plane, first angle projection. So it is 10 mm, sorry, 25 mm and 40 mm from vertical plane. So A is 25 mm below XY and B is 40 mm below XY. So with these data, is asking to complete the problem. With this data, he is asking to complete the problem. So instead of giving, so compare the data given in the previous problem. It is true length of the line, true inclination, and distance of 1 point from the reference line. 1 point means A dash and A point is given. So only 5 values are given. Here, the same 1, 2, 3, 4, 5 values are given. But the given values are different. Instead of giving theta and 5 values, inclination of the line with horizontal plane and vertical plane, he has given the data of the point B from the reference line or from the reference planes. So how to start this problem? When in any case the endpoints data are given, means the endpoint of A and B values are given. We'll start the problem in the, let me erase this. Now, first draw XY line. So this is the basic thing, representing XY. So after drawing XY line, so first we have to fix any point A or B. So let us fix point A. So draw A dash and B dash. A dash 10 mm above XY line and B dash, sorry, A dash and A 25 mm below XY line. A dash 10 mm above XY line and A 25 mm below XY line. If you refer to the configuration figure, so we completed representing these two values. Remaining B dash and B points from XY line is given, but we don't know the projection distance. B dash and B complete ga indicate cheyalante, we should know the distance from A also, not only from XY, we should also know its distance from point A. So we don't know that value. So in such cases, so whenever the data is given in terms of these 4 dimensions, we will follow a process. That is, parallel to XY line, draw the locus line first. So what is this line? This is locus of B dash comma B1 dash. B dash and B1 dash lie on the same parallel line to XY line, same locus. So observe the configuration figure. In the draw chema cheppan. Observe the configuration figure. B dash and B1 dash lie on the same locus, on the same parallel line to XY line. And in this problem, the distance of that particular point is given. B dash is at a distance of 35 mm from XY line. So XY line is 35 mm above from XY line at a height of 35 mm above XY line. Draw a horizontal line indicating the locus of B dash comma B1 dash. Similarly, B is 40 mm below XY line. B is 40 mm below XY line. So below XY line, at a distance of 40 mm, draw a parallel line. What is this line? B and B2 lie on the same horizontal line from XY line. Is it? B and B2. Observe the configuration figure. B and B2 lie on the same locus, means a line parallel to XY line in top view. So name on this locus of B comma B2. Write it on this. This horizontal line is indicating the locus of B comma B2. So means B and B2 exist somewhere on this line. B dash and B1 dash will exist somewhere on this line. Now we also completed representing these values given in the problem. Next, true length of the line is 80 mm. So true length of the line equal to A dash B1 dash. We know the location of A dash. B1 dash will lie somewhere on this locus. B1 dash will lie somewhere on this locus line. So with 80 mm radius, A dash as center, draw an arc on this locus line. Indicate this point as B1 dash. Join A dash, B1 dash. Previous problem ఏంటంటే angle and length are given. So directly with the respect to angle and the given length, we have drawn this A dash B1 dash line. But in this problem, instead of giving angle, it has given the location of the other end point from the reference line. So అందుకని ఇట్లా A, B రెండు పాయింట్స్ ఇస్తే ఫస్ట్ A ఫిక్స్ చేసుకుంటాం and B we're going to draw it as a locus line. రెండింటిని కూడా డైమెన్షన్ లాగా ఫిక్స్ చేయాలి. ప్రొజెక్షన్స్ డ్రా చేయండి. ప్రొజెక్షన్స్ ఎప్పుడు డ్రా చేస్తామంటే ద ప్రొజెక్టర్ డిస్టెన్స్ ఫ్రమ్ బి అని ఇచ్చారు అనుకోండి, ప్రొజెక్టర్ డిస్టెన్స్ ఆఫ్ ఏ డాష్ అండ్ బి డాష్ ఇస్తే అప్పుడు డైరెక్ట్ గా బి ఏ విత్ కీపింగ్ ద ప్రొజెక్టర్ డిస్టెన్స్ డ్రా చేస్తాం. బట్ హియర్ ద ప్రొజెక్షన్ డిస్టెన్స్ ఇస్ నాట్ గివెన్, జస్ట్ ఓన్లీ ఏబి పాయింట్స్ డిస్టెన్స్ మాత్రమే ఇచ్చారు. సో ఏ ఫిక్స్ చేస్తాము, బి యాజ్ ఎ లోకస్ లైన్ డ్రా చేసుకుంటాం. Now AB2 also equal to 80 mm. True length is also equal to AB2. So A only, B2 will lie on this locus line. So with 80 mm radius, draw an arc on the AB2 line and join, mark this point as B2, join AB2 with a straight line. Join AB2 with a straight line. Now, from now onwards, same as the previous problem. From now onwards, same as the previous problem. We know the true length of the line. Previous problem ko ide chesam kada. Drawn the true length of the line with the given inclinations. But here also I have drawn the true length of the line, but with different sequence. And from now onwards, both are same problems. So, you can change as you got B1 dash. B1 dash నుంచి projection horizontal line from A. The intersection point is B1. Similarly, projection from B2. Projection from B2 actually. Projection from B2, the horizontal from A dash. The intersection point as B2 dash. Front view lo eppudu dashes and top view without dash. So we got the respective points B2, B2 dash, B1, B1 dash. Finally, the final front view and final top view. So this is the front view length and AB1 is the top view length. So these are two lengths and this is front view length and this is top view length. So after completing this, take the distance compass. With compass, set radius equal to A dash B2 dash and draw an arc up to this locus line. The intersection point is B dash. Similarly, so if required, extend this locus line, measure the top view length, means the distance from AB1. AB1 distance measure chesi, A center, draw an arc up to the locus. This is the final projection of point B in top view. Join A dash B dash and AB with HB. the final front view and final top view. One more cross checking. Problem ekkada mistake lekunda exact chesamu ante meaning maintaining the drafter properly for drawing the horizontal and vertical lines. B dash will get it on the exact vertical line. So ikkada final ఏంటంటే the dimensioning is common. Before dimensioning, if you observe any problem of line inclined to both the planes, we'll have 3 projection lines in front view and 3 projection lines in top view. Final projection line A dash B dash in front view. Other than this, A dash B1 dash, A dash B2 dash. 3 projection lines in front view and 3 projection lines in top view. Final projection is AB. Other than this, AB2, AB, B1. So total 3 plus 3, 6 projection lines. And along with these 6 projection lines, 4 projectors. 4 projectors. That is AA dash, BB dash, B2, B2 dash, B1, B1 dash. So projection lines, projector lines means perpendicular to XY line. అవి కాకుండా 3 lines in front view and 3 lines in top view. So problem complete అవ్వాలి అంటే we should get total all these lines. 3 plus 3, 6 plus 4, total 10 lines other than reference line XY line and dimensioning. మొత్తం వస్తేనే ప్రాబ్లం కంప్లీట్ అయినట్టు. సో ఆర్ అదర్వైజ్ 3 points for B in front view, 3 points for B in top view, A dash. Now coming to dimensions, already I completed represent the dimensions 40 and 35 mm and also represent the dimensions for A from XY line. What are these values? 10 and 25. 10 mm above XY line, 25 below XY line, and one more data, that is true length of the line. So already చెప్పాను, true length of the line, if it is dimension intersect అవుతుంది అనుకుంటే కనుక requirement ఉంటే extend this for even 5 centimeters and then represent the dimensions. So but be careful, the dimension line must be parallel to A dash B2 dash line, and these extension lines must be perpendicular to A dash B2 dash. And finally, represent the value 80. So this is how to represent the dimensions and completing the problem. Let us, so sir, if you have any doubts regarding these two problems, unmute your audio and clarify your doubts. Otherwise, I will move on to the next problem, third problem. Actual lines inclined to both the planes low. Explanation of the problem takes a lot of time. Draw చేయడం easy. Why? Because only straight lines. No need of any curvatures or lengthy procedures. But the thing is, you must know the sequence of steps. Final converted drawing చూసి you can't identify where to start the problem unless you know the concept where to start. You can't finish the problem. So be careful. Problem to problem, starting points and ending points are varying. Final figure almost looks the same with the total 10 lines. 3 lines in front view, 3 lines in top view, and 4 projection lines. A problem just away lines ఉంటాయి with varying dimensions. But problem to problem, starting and ending sequence are varying. అది గుర్తుండాలి అంటే you must know the concept. A conceptual figure draw చేసుకుని అందులో ఉన్న రిలేషన్స్ ఎక్స్ట్రాక్ట్ చేయగలిగితే 70% of the problem is completed.
సార్ బీబీ డాష్ కూడా డార్క్ గా ఉండాలి సార్.
బీబీ డాష్ నో, అది ప్రొజెక్షన్ కాబట్టి 2H పెన్సిల్. ఓన్లీ A dash B dash AB ఈ రెండు మాత్రమే HB, రిమైనింగ్ ఆల్ అదర్ విత్ 2H. Now coming to next problem. I'll explain it from the textbook, a solid example only. So ఎందుకంటే textbook లో exercise problems అన్నీ కూడా a little bit complicated, which are not in our syllabus. On syllabus point of view, no need to go through that much depth. I'm sharing the screen.
సో ట్రేసెస్ లొకేట్ చేయలేకపోతే
ఓకే ట్రేసెస్ లొకేట్ చేయాలి. ట్రేసెస్ లొకేట్ చేయాలి అంటే సో మీరు ఏం చేస్తారంటే ఈ ఏరియా డైమెన్షన్ డిపెండింగ్ ఆన్ ద ట్రేసెస్ ఆఫ్టర్ కంప్లీషన్ ఆఫ్ ట్రేసెస్ రిప్రజెంట్ దీస్ డైమెన్షన్స్. Represent the dimensions. So let me complete these traces. Traces అన్ని ప్రాబ్లమ్స్ కోసం ప్రాబ్లమ్ లో అడిగితే కంపల్సరీ. If has not asked to indicate the traces, no need to represent the traces. But just for showing the process, I'm also explaining for this one. So traces draw cheyali ante extend front view. First extend front view and also top view line. So front view ante A dash B dash. Extend A dash B dash line and also AB line till it intersects the XY line and also extend it beyond the intersection. Now mark the extension of front view with XY line. Intersection of front view extension with XY line as H and top view extension line with vertical plane. Top with XY line. Top view extension line with vertical with XY line as V. Top view extension line, XY line intersection line V. Front view extension line with XY line intersection as H. So after getting H and V, so be careful, it should be in small letters only. Next, H inch vertical line till it intersects the extension of front view. Name this point as HT. HT must be with in capital letters. HT capital letters లోనే రాయండి. అలాగే V నుంచి vertical line till it intersects the extension of front view. Name this point as VT. Name this point as VT. So after drawing the traces, represent the dimensions. So dimensions, you could draw just say it will be overlapping. So extend it beyond the traces and then represent the dimensions. Okay. So with this, I'm stopping the video. Just go through the presentation. So we'll go through the midpoint problem after completing one or two problems on regular problems. Note on this problem. Problem number 10-11. Write it in the short form. Top view of a 75 mm long line measures 65 mm. So here it is given true length of the line and top view length. top view of a 75 mm long line measures 65. So true length is 75 mm and top view length is 65 mm. While the length of the front view is 50 mm. So both front view lengths and top view lengths are given. Both the front view lengths and top view lengths are given, and also the true length is given. So with this data, we have to start the problem. So also write down the other data. Position of one reference point is given. Point A, let us take it as point A. Point A is in HP and 12 mm in front of VP. Means A dash on XY line and A 12 mm below XY line. A dash on XY line and A 12 mm below XY line. Draw the projections of the line AB and determine its inclinations with HP and VP. So asking to calculate the true inclinations, theta and phi values. So here we have to identify the true inclinations, theta and phi. So what are the given data? Again, I am repeating. True length of the line, top view of a, so don't confuse here, top view of a 75 mm long line measures 65. So true length is 75 and top view length is 65. Front view length is 50 mm. Front view length is 50 mm. Its one end A is in HP, means A dash on XY and 12 mm in front of VP, means point A 12 mm below XY line. Asking to draw the projections and identify the value of theta and phi, true inclinations with HP and VP. True length 75 mm, top view length, front view length are given. Just you have the previous problems, compare it with the figure. True length equal to any of you? A dash?
A dash B1 dash.
Yes. A dash B1 dash also equal to A B2. A dash B1 dash also equal to A B2. Next, top view length. So top view length equal to 65 mm. Top view length is nothing but AB. Top view length equal to AB. So which is also equal to AB1. Top view length is also equal to AB1. AB1 equal to AB. Next, front view length equal to 50 mm. So front view is A dash B dash also equal to any of you?
A dash B2 dash.
Yes. A dash B2 dash. So first try to extract the given data and represent them comparing it with the configuration figure. If you do this thing, this basic writing, 90% of the problem is completed. Next thing is only representing these given data on the figure. First, draw XY line. So if we can remember the configuration figure and compare the given data with the configuration figure, maximum problem is completed. So be careful, don't be in a hurry. Take 10 to 15 minutes time for extracting the data and comparing it with the configuration figure. Even in the examination, what I suggest is, before starting the problem, draw this configuration figure on rough work and compare the problem given data with the figure. Now, first, a point A is on XY, A dash on XY, A 12 mm below XY. So let us represent point A. A dash on XY and A 12 mm below XY line. Next, front view length is given and true length. Anywhere the inclination values are not given. So how to start the problem? And anywhere the inclination value or the point B positions are not given. So ఎలా స్టార్ట్ చేయాలంటే top view length equal to A dash B dash also equal to A B1. So ఒకసారి configuration figure లో look how AB1 is. Any of you? AB1 line ఎలా ఉందో చూడండి previous problems లో.
Parallel to XY, sir.
Parallel to XY line. Similarly, A dash B2 dash also parallel to XY line. AB1 and A dash B2 dash, these two lines are always parallel to XY line. So as we know the line, so in the line draw cheyalante ikkada condition meer gurtupeట్టుకోవాలి. We must know both its length and dimension. Rendu telistene line draw cheyaгаlam. We know all these things, but angles we don't know. Directly ఇవ్వలేదు. So we can't draw any line directly. So but we know the condition that AB1 and A dash B2 dash always horizontal. So we know the orientation and length of the line. Line draw చేయాలంటే ఈ రెండు తెలిస్తేనే lines draw చేయగలం. Otherwise don't start the line. So AB1 is always horizontal. AB1 equal to 65 mm. We know the location of point A. So A నుంచి draw a horizontal line up to a length of 65 mm. So this is the point B1. Next, A dash B2 dash. A dash B2 dash is 50 mm. So A dash నుంచి on XY line. So ఈ problem కి మీరు XY line ని as light as possible draw చేయండి. So this is A dash B2 dash. Just for highlighting, I am redrawing on this line. మీరంతా డార్క్గా డ్రా చేసిన అవసరం లేదు. A dash B2 dash. Now we got B2 dash and B1 points. So ఎప్పుడైనా సరే B1 వచ్చింది అంటే try to mark the B1 dash. అలాగే B2 dash వస్తే try to get the B2 point. So B1 point వచ్చింది. So B1 dash must lie on the same projector. B2 dash B2 lie on the same projector. So B2 dash ఉంది కాబట్టి extend it to top view. B1 top view location తెలుసు. Extend this line to front view. A vertical line perpendicular to XY. Now on this perpendicular line you must get B1 dash, and on this projection line we must get the point B2. So B2 dash వచ్చింది కాబట్టి B2 must be on this projection. Similarly B1 వచ్చింది కాబట్టి B1 dash must be on this projection. So B1 dash B2 dash రావాలి అంటే we know the true length. True length ఏంటి? 75 mm. It is nothing but A dash B1 dash. True length equal to A dash B1 dash. So A dash నుంచి 75 mm radius తో ఆర్క్ డ్రా చేస్తే B dash నుంచి వచ్చిన ప్రొజెక్టర్ మీద we will get B1 dash. A dash B1 dash. The length of the line is given. So join A dash B1 dash. Similarly, 75 mm radius so AB2 is also equal to 75 mm, true length of the line. AB2 is also equal to 75 mm length. So A center 75 mm radius to arc draw cheste on the projector from B2 dash. We will get point B2. So two trapeziums వచ్చేసినాయి here. Front view inclination, top view inclination. finally getting the inclination of the line when it is inclined to both the planes. So inclined to both the planes, before that, just for the, I'm drawing this true length of the line, and this is also true length of the line. What is AB2 dash, A dash B2 dash? Front view line, and AB1 equal to top view length. AB1 equal to top view length. Now draw the line parallel to XY line passing through B2 and B1 dash. What is this? Locus of B dash, and this is locus of B. Locus of B dash and locus of B. After drawing locus with radius equal to A dash B2 dash, with radius equal to 50 mm, already given in the problem. A dash B2 dash, draw a line arc up to the locus line. Draw an arc up to the locus line. Similarly, with radius equal to AB1 radius flow, A as center, draw an arc up to this locus line. This is point B dash. Point B dash, join A dash B dash and AB. Join A dash B dash and AB, and also B dash with 2H. B dash with 2H. So final B dash correct ga draw cheste, we'll get a line perpendicular to XY line. And finally dimensioning. So observe cheyandi, finally you are getting the same figure almost, just with different lengths or angles. But where to start the problem is important. So I'm just concentrate on where to start the problem. So first step is try to extract all the given data from the problem in this short form. And then represent each and every value on the figure. Try to represent graphically each and every dimension wise. And then complete the given line, other lines. Configuration figure complete avali. So draw the remaining lines. So take it as a challenge or a puzzle. So make up interesting. In each and every problem has different sequence of steps. So almost 6 problems I am planning to discuss, and all these 6 problems have different sequence of steps, but finally getting almost the same figure. So if any of having doubts, unmute your audio and clarify your doubts. Otherwise, you can leave. Meanwhile, let me take the attendance. Roll number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 16, 17. 100% present, but roll number 209 attending from 11:39 onwards. Attending the class from 11:39. (202) attending the class from 10:45. What happened? 221 also attending the class from 10:45, not from 10. Already మీకు previous class 9:50 కి అయిపోయింది, but still you have joined the class from 10:45. 229 only present for 35 minutes from 11 to 11:35. 36 I'm marking absent. Just attended for 1 minute. So నాకు టైం కూడా రికార్డ్ అవుతుంది. Not only your attendance, final attendance కాదు. I can see your time when you have joined and when you have leave the session. 2:36 I'm giving absent.
Sir, I joined at 9 o'clock, 10 o'clock only, sir.
10 join అయ్యావు బట్ ఇమీడియట్ గా లిఫ్ట్ అయిపోయావు.
No, sir.
But that's all represent. Okay, can leave the session. డౌట్స్ ఏమైనా ఉంటే కనుక అన్మ్యూట్ చేసి డౌట్స్ క్లారిఫై చేయించుకోండి, అడగండి, ఆర్ అదర్వైజ్ యూ కెన్ లీవ్ ద క్లాస్.